come here, but then within the 2's it's sorted in alphabetical order, because like a string, if the first character matches, then it looks to the second character, and then we see, oh, here we go, the 3's, and then the one we actually wanted, the highest one, is the 7. And so one of the things we can do is we can say, you'll notice that we want the highest one, not the lowest one. So we can just tell this with this parameter, reverse equals true. And we just say, hey, sorted, do this backwards. Do it from highest to lowest rather than lowest to highest. And now our sorted one says 7, the, etc. Okay? And so if we want the first 5, we can say up to but not including 5. So this is now the top 5. So the sorted one is, that's the top 5. If it's a tie, we're going to go in reverse alphabetical order, but let's not worry about that too much for now. So it makes a flipped list, then it sorts the flipped list. Now, if I just wanted to print it out nicer, I could loop through this new list. I could say for v comma k. Remember, this is a flipped list, so the sensible thing is what's coming out of this list, each tuple is value comma key in temp, and I'm only going to go up through but not including 5, so the first 5. And so I'm pulling them back out as value key because that's what they are. They're value key, see value key, value key, value key. So V is going to go through these and K is going to go through these, and then I'm just going to print K comma V. So this is kind of my flipping backwards because I want to see them this way. And the is the most common one, car 3. And so it's just going through this up through the 5th one and then printing them out. Okay? So let me comment this out. Let me comment that out. Let me just delete this. So we have a dictionary. Let me comment out the dictionary. We have a dictionary. We make a list, and we make these reversed tuples where we have the value first and the key second. We're setting it up so the sort's going to work. And then once it's sorted, we have to flip them back. So we flip them for sorting from key value to value key for sorting. We do the sort, then we flip them back with key value and print them out. And it works fine. So let's try our big file, intro.txt, and there you go. Those are the 5 most common words in intro.txt. So you might ask yourself, why did we use tuples? We could have really used lists for this, but tuples are more efficient than lists, and you notice that we weren't going to modify. We did modify the temp list. It's a list of tuples, but the tuples within the list we weren't going to modify. And so we tend not to make lists if we can get away with using tuples. And so that's why we made this this flipped tuple thing. Okay? So I hope that was useful to you. Hope to see you on the net.
Hello and welcome to Chapter 11, Regular Expressions. The fun thing about this chapter is, unlike all the rest of the chapters, you sort of had to really understand every single thing in chapters 1 through 11 built on one another, 1 through 10 built on one another, but you can really get along without using chapter 11. It's not a really required topic, but it's a fun topic and an interesting topic. So so you can relax a little bit and realize that you may or may not like regular expressions, and if you don't like them, that's okay. You don't have to use them. You can go for your whole life without using regular expressions. The idea of a regular expression is that you come up with a language. It's a little character-based programming language where you can do smart searching, basically. Smart searching, and as you'll see in a bit, was smart extraction, and it's really almost programmable wildcard expressions. There's no looping, but there is looping, and there's all this implicit thing. You say, look for patterns that look like this, and then you get back things that match those patterns. You know, we do searching for everything. We're looking through large blocks of text, say, go find me everything that has the word Python in it or something like that. So that's just such a common thing to do, and regular expressions are a very structured way to go about searching for information. They're very powerful, but they're also very cryptic, and you may not like them, but they're a lot of fun actually once you understand them. Learning how to program them takes a while. Writing good regular expression programs requires some try it, play with it, check it, try it, check it, try it, check it. But once you get them, they're really quite cool. It's a very old programming language. You know, it comes almost from the 1960s. The concept of, it's a theory of computing where they were trying to come up with theory of languages, and regular expressions was one form of languages that computers could understand. And so it has some fun old words. And one of the advantages of knowing regular expressions is that you're kind of a cool person. You can take a quick look at this XKCD that sort of captures the devil may care awesome power that regular expressions do. And while we're at it, you know, while we're talking about awesome, I do want to take this moment and show you my awesome tattoos. And so you may not know this, but I got a couple tattoos here. Here's the first tattoo. This is where I got my PhD, and this is my University of Michigan faculty member position. I got PhD in engineering, and I teach in a school of information and library science. And then I have this other tattoo, and this tattoo is what I call the Ring of Compliance. I work on learning management systems and educational technology and standards, and there's this standard called Learning Tools Interoperability, which if you're using this course and doing the autograder, it uses Learning Tools Interoperability to integrate into whatever learning management system you happen to be using. And one of those learning management systems is the open source learning management system that I helped write called Sakai. And these are the rest of the major vendors. And the idea of that tattoo was that I would put the tattoo of every vendor that would comply with Learning Tools Interoperability. And so you'll notice Coursera. I helped Coursera put Learning Tools Interoperability in. And so the autograders integrate into Coursera or Blackboard or Canvas or Sakai or Moodle or half a dozen other things. So it's just like a cool techno thing, just like regular expressions. So I've got a URL here for regular expression quick guide. You might want to print this out so that you can look at it even while you're watching this lecture, because it's a little programming language, except that it's character-based, not line-based, and not keyword-based. It has certain active characters that the character means something versus the character represents the character itself. And so the regular expressions is not part of the base Python, but it's distributed with Python. So you have to put an import RE at the top to say that's really saying pull in the regular expression library. And there is a couple of functions inside that, re.search, which is kind of like a really smart version of the find method inside of strings, and re.findAll, which is kind of like taking and stamping your way through a loop, through a string, and finding all of the things that match a particular pattern and then extracting those. And we'll talk about both of these in this lecture. So here's a really simple piece of code where I'm just going to sort of show you sort of before and after. So here's a thing where we're looking for lines that begin with from : and so we open a file, we loop through the whole file, we strip off the lines text, and then we say if line.find from is greater than or equal to 0, then we print it. It gives you -1 if it's not found, and so reads all the lines, and once in a while it'll print it out, reads all the lines once in a while, print it out. So that's kind of like a needle in a haystack. To use regular expressions to do that, we have to import the regular expression library. These lines are the same. We're going to loop through, we're going to strip. And now we're going to say if re.search. The way to say this is within the library regular expressions, go find the search function and search for the string from in the string line. Okay, so this is the line to search, whereas here it was more object-oriented where we say line.find. Here we say re.search and we pass in line as parameter. These two things are equivalent, which means most of the time it's going to run, and once in a while it'll hit a line and it'll print that out, and then it'll finish the whole thing. So that is taking and doing what we would do with the find operation with regular expressions. Now, searching with regular expressions has these special characters, and so here we have the same basic code, except now we're saying if line starts with from. So we're not using find anymore. And that way we're only going to get that thing in the first position, not like blah, 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 blah from : We don't want that to match. We only want it to match here at the beginning of the line. And so that's what we use line starts with. So it's going to do the same thing and find lines that have the prefix and print those out and then be done. Now in regular expression search, we don't in a sense, change the method. We have a certain number of things we can do with strings based on what they've built in. But in regular expression, we actually can turn this first parameter into code. And so what's happening here is the caret, if you go back to the little cheat sheet, caret means this is the beginning of line. It's a virtual character